Hello everyone, the preview release of Malt 1.0 is already out, and the main new feature is render nodes. These are quite different to how other engines handle this kind of thing, so let's take a look at them and how they can be used. So we are in the default Blender startup scene. If we switch the render engine to Malt, okay, Malt starts, and automatically there are new nodes imported. We have the default mesh. Right now we can see the cube because the light is too far, so we are going to convert it to a sunlight, and we are going to add a plane. Okay, much better. Mesh shaders work more or less the same way, although the nodes API has been heavily improved, and the outputs work a bit differently, but we will check this later. As I said, the main new feature are render nodes, and this basically allows you to modify the whole render pipeline directly in nodes, just like it was possible previously with Python. And most of the render parameters are now here, instead of the scenes parameter are no longer here, and in the world parameters there's just some remaining settings that didn't make too much sense to put into nodes. So as you can see here, basically the renderer receives the scene, render the lights. Here are all the lighting and light map related information. Render layers renders all the scene geometry. This is a screen shader that renders the background. Okay. And finally the anti-aliasing. A useful thing for modifying your render style will be probably done inside the render layer nodes. Basically, this is what happens inside this node. Okay, it receives the scene, and right now is returning a color, but it could return more textures. So let's take a look at here, and it's kind of similar. It receives the scene, it renders the prepass that basically renders the normals, and the textures, and the ID, which is later used for things like amino occlusion and basically anything that sits under filters needs these previous textures. Then, well, it does more things, like for example the custom light shaders are also done in the prepass. Then the main pass is usually where you do the main shading and the lighting and anything like that, and then it finally does the line render. So here you can see how right now previously we have only one output for pixel shaders, and right now we have the main pass in the prepass. This already worked this way in the previous version, but now is explicit, it's not hidden. So you can see how the outputs here are the same outputs you have here. This can be controlled here in properties. You can add any AOV of any type you want. Let's say before, and if we reload, we have to reload because this sometimes can be slow on large scenes since shaders have to be recompiled. But we hit reload, and we can see we now have this output here. We can do this with almost any other output. In pre-pass, we can also add extra outputs. Right now, if we set something like red and we output this, see it. And the same for render nodes and render layer nodes. So here you can also add extra outputs. And the same for render outputs, and this is basically like plain AOVs. If we press F12, we have the convenient output and the custom output. Okay. It works also for inputs. So we can, for example, create a screen shader, create a new material with a need node 3. We plug this in. Here, these nodes that take a scene parameter as input, like the main pass and screen pass, these normal and ID sockets are optional. If you don't plug anything, it's basically reading the outputs from here. It's just automatically, but you can override it if you want. So that's what we are going to do here. So we add our output. Let's say custom normal ABEX free and reload. And one of the new features of screen shaders is that we now have access from here to some of the Mpr pipeline API, like filters and even shading, and basically it tries to act as a mesh shader whenever possible. So you can, for example, even in common, if we take the surface normal, let's change this to a custom output before, since otherwise it won't work on due to the multiple layers. So we reload and plug this here. We always, if we use screen paces inside render layers, we have to make sure that the layer only option is enabled, otherwise it won't work. Oops, is this output? Okay. See, if you don't check this, you are basically watching only the last layers, and since in this case there are no transparent objects, you can see anything. So okay, as I said, we are going, for example, to take the bevel node. Let's plug this back. Okay, so we can see the actual result, and we are going to bevel basically everything. Right now we can see the the difference, but if we output our custom normal into our main pass, it's not too obvious because of the color. Let's change that. Default mesh. Let's remove this. Let's going to change this for. Here you can see how the mesh shaders have access to the Mpr shading, which is basically the more lower level access to these functions, where you can select if you want shadows and cell shadows and what group. You can even override the position and the normal. But in mesh shaders we also have this easier to use API, which is basically the same but with less options, and instead it uses the options from here. Okay, so let's go into output this. Here you can see how the edges are beveled. Let's go back to, let's rename this to bevel and reload, because otherwise the render can't find the shader. So if we remove this and replace this with dip, here you can see the difference. Okay. And it can be useful too to do things globally, like if you, for example, know that you want ambient occlusion on all your materials, and you want to use the same settings on all materials. You can just calculate it here. Okay, we can preview by plugging it. Let's go into add it more strength with blood power float. Okay, this is maybe a bit too much. And we could, for example, add it to mesh shaders as a custom input. So here in input, main pass pixel shader input, let's call it ambient occlusion. And we are going to multiply. We have to sample the texture. By the way, Malt nodes don't have search functionality, but you can use F3 for the search operator menu. So you can search here instead. So sampler 2D sample, and this by default. Let's going to plug this. Is this one? Yeah, it's this one. By default, this is going to read the texture using the mesh UVs. So yeah, if we put this and let's read this back, see, this is basically broken. What we have to do is to read it using the screen UVs, which is in transform screen UV. I usually use F3, but here I'm trying to use the menus Okay, see this one. This is working. So you can see the where this is located in the menus. The samplers are here. Okay. So we are going to multiply just to towards the. Okay. And now we have both things combined. And yeah, this can be applied to anything. We could create another. Oh, by the way, this might be a good time to teach you this. You can optionally hide the settings from here. So here, if we disable this, see, we remove most of the options. You can just leave only what you want to be overridden in the material instance. So we are going to create another screen pass. Again, we are going to plug the scene. This one we are going to call it line. Again, select the type of shader. By the way, some of the outputs are per graph, and some of the custom input output is global. So basically, if we the inputs and outputs of mesh shaders are global, if we create a new mesh shader, the outputs are going to be shared. Okay, see, we have the same as in the default mesh, because otherwise you couldn't use the same materials. I mean, several materials in a main pass or a pre-pass. But for things like screen pages or render layers are per instance, since basically a screen pass is only using one material, and a render layer like here is only using one node tree. So are per instance. So let's go back. Okay, we have not added an output yet. So we are going to add a line color. And line width. Reload. So we are going to leave the color from here, but instead of plugging it directly from materials, we are going to calculate it globally from here. And here in filters, line width, this node have changed it quite a bit. I'll probably do a tutorial specifically for the line node, since this is heavily used everywhere, probably for most of the Malt users. So I think it works. By the way, I changed the default sample size. It used to be 1.5, which sorry, here, which makes things smoother, is especially obvious with line and things like that. But yeah, I think depends on the use case. I would like to know what do you think should be the default value. And another thing I added in the 1.0 user experience proposals, I say that I wanted to add something like for controlling the line width. So what I ended up doing is simply add a line scale here in the node, so you can change it globally. And now nodes also have parameter overrides, so you can, for example, add an override for the final render. So if you know you are working on a small viewport, and there you are going to always render at 4K, for example, here you can see how the render line width is double the size of the line width in the viewport. Okay. So I think this is most of it. I created a post with the release notes here. You can also get this sample file with most of the commonly used features that you can use as a reference, and you can download it here. Okay. So that's it for now. Thank you for watching. I hope you like these new features, and if you want to help me keep the development of Malt going on, you can go to patreon.com/pragma37 and support the project. Thank you.